Okay. Moving on to the handouts. Right. So we are going to look at an application of what we had just done. Sit here. Okay, so we'll see the application of this one is the application. Okay, so let's start from number one. Number one. So we were somewhere.
Paul can clean a classroom floor in 3 hours. When his assistant helps him, the job takes 2 hours. How long would it take the assistant to do it?
So Paul can clean the classroom. So what you do for us, you read. So you read this, the application problem, and then you identify what they are looking for. So in this case, they're looking for how long would it take the assistant to do the job. So we have that Paul text, clean the floor in 3 hours. And then when his assistant helps him, the job takes 2 hours. How long will it take the assistant to do the job? So the question is, in 1 hour, what is the amount of job that Paul would have done? And then in 1 hour, how far will the assistant would have done? And then in 1 hour, how far will both of them would have done? So what you do is, for Paul can clean the classroom in 3 hours. So in 1 hour, this guy will have done 1/3 of the job in 1 hour. Then if they're doing both of them, then it is Paul plus the assistant. They will have done 1/2 of the job. They will have done 1/2 of it. Now, how long will it take the assistant to do the job alone? So if Paul can take 1/3, if Paul can do 1/3 of the job in 1 hour, and both of them can do 1/2 of the job in 1 hour, how about if the assistant do the job? So how far will the assistant do the job in 1 hour? So for Paul, it is 1/3 in 1 hour. So 1/3. Plus, we can say the assistant is X. So 1/X is equals to what? 1/2. If they do it if both of them will do it. If both of them could do it. So it is similar to if one of them does in 1 hour, they will have done 1/3. And if the assistant does it 1 hour, you have done 1/2. But if both of them do the job, they will do it in 1/2. So what is this x here? So what is the value of x? So using the methods that we've used, so what is the LCM of the three of them? What can cancel the three of them? 6 what? 6x. So 6x. So 6x here multiplied by 6x here. So what we get is we multiply each one of them by 6x. So the first one will give us what? 2x, right? So 2x. The second one will give us what? Plus 6. And that equals to what? The last one here will be what? 3x, right? 3x. Now you collect the like terms. So you can take 2x to the other side. So you can take 2x to the other side. You get 3x minus 2x equals to what? Equals to 6. Equals to 6. So you take 2x to the other side. So our x equals what? 6 hours. So the assistant will do the job in 6 hours. The assistant will do the job in 6 hours. Are we together? Okay. Number 2. Read for us number 2.
Washing his dad's car alone. 8-year-old Levi takes 2.5 hours. If his dad helps him, then it takes 1 hour. How long will it take Levi's dad to wash the car by himself?
So it's similar to the first one there. So if Levi can take 2 hours to wash it alone. So so we can say Levi takes 2 hours, 2.5 hours to do it alone. If his dad comes an hour, then it takes it 1 hour. So dad plus Levi, they will take 1 hour. So how long will it take dad to clean the car? So it is similar. So in 1 hour, Levi will have done 1/2.5 of the job. And then in 1 hour, the two of them will have done, so they will be done in 1 hour. So they'll actually be done in 1 hour. So how about when the dad does it alone? So it will now be 1/2.5 plus 1 over the dad, yeah, equals to what? Equals to 1. So our least common multiple there is 2.5 what? And then this one is 2.5. So when we multiply each one of them by 2.5d, so the first one will be d, plus the second one will be 2.5 equals to 2.5 equals 2.5. So you take d to the other side, you get 2.5d minus d equals to what? Equals 2.5. So what remains here is 1.5d equals to 2.5. So our d equals to 2.5, 1/1.5. Our d equals to what? 5 over 3 hours. Oh, you can convert it to, so that is like 1 hour. How many minutes? 1 hour. So you can convert it, so you can multiply it by 60 minutes. or you can just leave it like that. So that's actually like 1 hour, 40 minutes, 1 hour. 40 minutes. Any question after that? Any question? Okay, you can try number 3. So you can try number 3. The number 3 says beta takes 3 hours to more than 1. Well, have to 2 hours. How long will it take? 10 hours. So in 1 hour, these will have done 1 over 3 of the job. And then the cousin will have done 1 over 2 of the job. Now, in 1 hour, how long will both of them? So simply, so Lisa is 3 hours. Bob is 2 hours. So you can say Lisa plus Bob equals to X hours, okay? X hours. So now, in 1 hour, Lisa will have done 1 over 3 of the job, plus Lisa will have done 1 over 2 of the job, and both of them will do 1 over X. So our least common factor here is 6x. So 6x, 6x. So when we multiply by 6x here, you get 2x plus 3x equals to what? Equals to 6. Equals to 6, right? 6. So this is 5x equals to 6. So our x equals to 6 over what? 6 all over 5. 6 all over. So both of them will do the job in 6 all over 5 hours. Okay. Okay, we can look at number 5. So we can read for us number 5.
Ethan walked on an asphalt path for 12 hours. He walked the 12 miles back to his car on gravel road through the woods. On the asphalt, he walked 2 miles per hour past through the woods. Walk on the gravel is 1 hour longer than walk on asphalt. How fast Ethan walked on gravel?
Okay, so here we are going to consider, the so you need to recall this. So the distance equals to speed times what? This time, right? And then if you want to get the speed, then speed equals to distance over Then if you want to get the time, so time equals to distance all over speed, and equals to distance all over speed. So you need to remember those. So you need to remember this. So this question says, Nathan walks on an alpha pathway for 12 miles. So the distance is, so distance equals 12 miles. He walked the 12 miles back to his car on a gravel road through the forest. So this is part, and this one is the same distance, 12 miles on the one. Gravel road. On the same asphalt, he walked 2 miles per hour faster than on the gravel road. 2 hours per hour faster. So the speed here. So on the asphalt, he walked two miles faster than. So if this one is, if you take this one as the speed as g on the gravel road, so this is the speed here. So the speed in this case on that one will be what? 2 hours faster, 2 miles faster, right? 2 miles per hour faster. So it will be g plus what? G plus 2. So looking at this, on the alpha, it walked 2 miles per hour faster than on the gravel road. The walk on the gravel took 1 hour longer. So it took 1 hour longer. So that means the time here took 1 hour longer than the time on the how fast did he walk on the gravel? So what is this guy looking for? The speed on the one, on the gravel, right? So in this case, because we are considering time here, so that means we're going to use what? The time equals to distance over the speed. So the time that this guy will use on this road, on the asphalt, is the distance over the time. So the distance is equals to what? 12 miles. All over, sorry, the distance, so time equals to distance over what? All over speed. So the distance that, the speed that you will use here is what? G plus what? G plus 2. Then again, it says, the work on the gravel took 1 hour. So it took 1 hour longer than the work on the so now looking at this, so in this case, he walks, this one is they walk 12 miles. Each one of them, right? So they're walking 12 miles. So he's walking 12 miles. So when he's going, he's using the asphalt. When he's coming back, he's using the gravel road. Okay. So the time that it takes from here to here is different from the time that it takes from here to here. That means the time from here to here is faster than this time from here to here by how many hours?
1 hour.
By 1 hour. So therefore, the time that it takes all the alpha is now 12 all over G plus 2 plus 1 hour, right? Equals to the time that it takes on the what? On the gravel road. And the gravel road is what? 12 miles all over what? Are we together? So the time that it takes is working faster when he's using the alpha. Now, on the gravel road, it takes that time plus 1 hour of the other time for what? For the alpha. Now, to get this time here, then it is the speed all over, the distance all over the speed is similar to that time that he used to travel over here plus 1 hour. Okay, because definitely this will give us the exact time that he will use from here to here. But now, when he is going from this point to this point using the alpha, then he takes that time using the alpha plus 1 hour to be equal to the time that he uses from here up to. Are we together? Are we getting that? So let me explain it again. So there is this guy who is going this way, right? So from here to here is 12 miles. It's 12 miles, okay? And then coming back again, and this one is on the asphalt. 12 miles. Again, coming back to where the car is, he uses a gravel road. Uses a gravel road. But now, the distance, the speed here is going 2 miles per hour faster than coming back. So if the speed here is G, then the speed here is what? G plus what? Plus 2. Now, the distance, the speed, the time that it will take from this point to this point is faster by 1 hour from here up to here. Okay, so is faster by 1 hour from here up to here. So that means the time from here to here is equals to the time that it will take from here up to here plus what? Plus 1 hour. Plus 1 hour. Because we exactly know the time from here up to here is the distance all over the speed. And the distance is 12 miles. All over its speed is what? And then again, the distance that you will take from this point to this point is 12 all over G plus 2. Now, since this time, so for it to be equal, to have the same time, that means you add 1 hour here, right? And this one, it will be now equal to the time there. So it will be now 12 all over G plus 2 plus 1 hour equals to 12 all over. Okay. So they will now be equal. So now you now solve it. So our greatest least common factor there is what? So we have 12 all over G plus 2 plus 1 equals to 12 all over G. So our factor there is G plus 2, right? That here, G plus. Okay. Okay. So when you multiply this and this will cancel with that. You get 12. When you multiply 1 plus multiply by this, you get what? Plus G plus G equals to this G and that one cancel. There's a 12 G plus. Are we together? So you need to remove the denominator by multiplying by the least common factor. And our least common factor is G plus 2. So you multiply each one of them. So now you open the bracket, so 12G plus G squared plus 2G equals to 12G plus what? So collect the like terms. So definitely this one and that will cancel. Okay, so you remain with this, and 24. So we have G squared plus 2G. Now you bring the 24 to the other side, minus 24 equals to 0. So you form now a quadratic equation. Then you see whether it's a perfect square. Is it a perfect square? It is not, right? So you use the AC method. So the product is minus 24 and the sum is 2. What are the two numbers? 6 and 4, right? So 6 and 4. Which one is negative?
4.
So 4 is negative. So G squared plus 6G minus 4G minus 24 equals to. So group them, G plus 6 minus 4, G plus 6 equals to 0. So collect G plus 4, G minus 4, G plus 6 equals to 0. So using the zero product property, so we take the positive one, right? So we take the speed, which is positive. So our G equals to what? 4 miles per hour. So what was the question? Walk on the ground. How fast did he walk on the ground? 4 miles per what? Any question? Okay, so you try the next one there. Try the next one. So it is actually similar to previous. So remember the exam is next week on Friday. Second exam is next week on Friday. It is going to cover from where we left up to chapter 7. So it will be 5, 6, and 7. Okay. So Harrison travels 1080 miles in a jet. So this guy travel. So we can say 1080 miles. This one is there. Then 240 miles by car. So another 240 miles. And this one is the car. To get to the business meeting. So the jet goes 300 miles per hour faster than the rate of the car. So we can say the rate of the car is what? C. This one will be what? C plus
300.
C plus 300. C plus 300. And the car ride takes 1 hour longer than the jet. So the car ride takes 1 hour longer than the jet. So what is the speed of the car? What is the speed of the car? So we solve the same way. So in this case, we are trying to get a what? The speed. The speed. And then we are using the time. So the distance, this time equals to speed, distance, over speed. Distance over speed. So the distance for the jet is what? 11080 miles. All over the speed for that jet is C plus what? Now it takes, the jet goes 300 miles faster than the rate of the car, and the car ride takes 1 hour longer than the jet. So what are we doing to the time for the jet? For it to be equal. So what do you do? So that means the time that this guy will take here will be the time that he uses plus the extra time for it to be equal to the time for the car, right? So, so now in this case it will be 1080 over 3C plus 300 plus 1 hour equals to what? Equals to 240 all over what? All of this. C. So the time that it will take for the car is the time for the jet plus 1 hour. Now, for it to be equal, then you now just equal to that. So just like the top one there, so you multiply by the least common factor, which is C plus 300 multiplied by C. So what you get is 1080 C plus C plus 300 equals to 240 C plus. So then you open the brackets, you find the C, and you should get C to be equals to 60 minus 60 minus Okay. So number 7, I think it's similar. So we can try number 8. So we can do number 8. Okay. So someone can read for us about it.
Jill training for trials. She spent a total of 2 hours riding the bike. She biked 12 miles. 6 miles. Her rate of minutes 10 miles per hour.
Okay, so you was trained. So she planned a day of exercising. She spent a total of 2 hours riding her bike and running. So bike and running. So bike plus running. This guy will take 2 hours. 2 hours. Bike and running. She biked for 12 miles and ran for 6 miles. So bike 12 miles. Running 6 miles. Her rate for running was 10 miles per hour. Less her biking rate. So the rate of running will take so we can say, so we can take biking. And then you can say here the speed. Start here. So biking will take the speed of so distance is 12 miles. And then running, it will take distance of 6 miles. Now, her rate for running, so the speed for running was 10 miles per hour less than her biking rate. So if the rate for biking is B miles per hour, then for running will be what? For running will be what? Less, right? So 10 miles per hour less than her biking rate. So it will be B minus 10. Now here, this lady will cover the distance, both the distance in 2 hours, biking and running. So therefore, we know that time equals to speed, distance over what? Distance over speed. So the speed, the time for biking is now the distance, which is 12, all over what? All over B, right? Plus 6 all over B minus 10 equals to how many hours? Equals 2 hours. Because it will cover the two of them in 2 hours. So what is? So the question is, what was her rate when running? So we are looking for the rate when running. So again, you multiply by the common factor, which is B minus 10, and B minus 10. So when you open these brackets, so this B will cancel with 1, you get 12, B minus 10, plus B minus 10 will cancel with that, you get 6B equals to 2B, B minus 10. So when you open these brackets, you get 12B minus 120 plus 6B equals to 2B squared minus what? 10, 20. Minus 20. Are we together? So we collect the right terms. So 12B and 6B are what? 18. We take it to the other side. So 2B square, which is this, minus 20B, we take minus 18B, the other side, and we take 120, it will be plus 120, equals to what? Equals to 0. So we take this one to the other side, we take this one to the other side, we also take that one to the other side. So 2B square minus 20 minus 18 is minus what? 38B plus 120 equals 0. So we can factor out what? 2. So when you factor out 2, you get B square minus what? 38 is what? 19B. That's what? 60 equals to. So we can actually remove the 2 because it doesn't, you can divide by 2 everywhere. So 2 will go. So since that one is not a perfect square, then we look for 2 numbers in which the sum is 19 and the product is 60. So what are the 2 numbers? What are the 2 numbers? 15 and 4. So which one is negative? Both of them, right? So B square minus 4B minus 15B plus 60 equals to 0. So B minus 4 minus 15, B minus 4 equals to 0. So we have B minus 4, B minus 15 equals to 0. So we have our B to be equals to 4 or B equals to 15. B equals to 15. Now, if we look at this, then which B are we gonna check? We are not going to take B as 4, right? Right? Because when you say here, 4 minus 10, you get a negative, which we don't need. So that means our B will be what? 15. So you take our B, 15. So now, what is the speed for running? So it is what? 15 minus 10, which is equals to 5 miles per 5 miles. Any question after that? So, you can actually do number 3 there because that is what we covered last week on Friday. I mean, the quiz that we had here. I will give you another quiz next week on the same. Any other question?
That's a register.
Yeah, but since most of you turned in last week on Wednesday, then maybe I'll send the quiz, but I think I'll give you the quiz on Monday. So make sure you do your homework. So try to finish your homework. So I'll grade everything. So if you've not given me anything, the quizzes, I'm grading them this weekend. So I'll post them by maybe tomorrow or today. So make sure you've done all the quizzes, all the homeworks by the end of the day. So if you've not given me any quiz, I don't think I will give you a 0. So make sure you bring all.
I can't see the figure this now.
It's you guys.